Good. Let's go to an activity two, which is about pesticide production and pollution law. So, per what we've studied so far, we've learned about how to optimize a problem. Good. So here there is a problem here that we need to also use the same principle to optimize it. So a factory produces two agricultural pesticides A and B. For every barrel of A, the factory emits 0.25 kg of carbon monoxide and 0.60 kg of sulfur dioxide. And for every barrel of B, it emits 0.50 kg of CO and 0.20 kg of XO2. So the pollution law restricts the factory output of CO2 a maximum of 75 and CXO2 to a maximum of 90. So those are the restrictions on it. So the number two is saying that we should find a system of inequalities that describe the number of barrels of each pesticide the factory can produce and still satisfy the pollution law. So we should graph the feasible region, that is the region that satisfies all the constraints that we are going to write. So will it be legal, that's number three, for the factory to produce 100 barrels of A and 30 barrels of B per day? So that is the question here. So now, what is the problem? The problem here is to know the feasible solutions so that the factory will be able to be in line with the production of the barrels whilst they will be restricted in the release of pollution of chemicals, and those chemicals are CO2 and SO2, CO rather, and SO2. So the maximum that they can produce out for the CO is 75, and the maximum that they can produce out for the SO2 is also 90. So they don't want to go against the law. So how are we going to solve this problem using optimization or linear programming? So here we are going to define our variables. Our variables are the production of pesticide A and pesticide B, so that will be in limit, will be within the constraint. Good. So we have x equal to the barrel of pesticide A, y equal to the barrels of pesticide B. So here, look at this particular table. When you go to pesticide A, we can produce 0.25 of CO and 0.60 of XO2. That is for the pesticide A. And when you go to the pesticide B, this time you can produce 0.50 of kg of CO and 0.20 of kg of XO2. And the maximum that we can produce for the CO is 75. The maximum that we can produce for the SO2 is 90. So if we want to write the constraint is such that after the production of the pesticide A and pesticide B, when I add the carbon dioxide produced, the carbon dioxide is supposed not to be greater than 75. So look at it. So it means that the sum of the carbon dioxide produced from pesticide A and pesticide B supposed to be 75 and below. So it's supposed to be less than or equal to 75. And the same applies to SO2. They are after the production of these two pesticides, their SO2 summation supposed to be less than or equal to 90, because that is the constraint given to us. So we are going to end up with an inequality sign of this form. So in order to make the expression easy for us to solve, we eliminate the decimals for easy graphing. So how do we do that? I divide both sides by 0.25 here, and I end up with this relation or this inequality. I also divide both sides of this equation by 0.20, and I also end up with this particular linear inequality. So we know that x is always greater than 0, greater than or equal to 0, y is always greater than or equal to 0, because after production it might be 0 or more, or here too the y might be 0 or more. That is the pesticide B, x and y, and the x represent the power of pesticide A, the y represent the power of pesticide B. Good. So look at this particular activity. We are still on it. We have to plot the graph, and we know how to plot the graph of this particular inequalities. So look at x plus y, this equal to 0. We turn all of them to inequalities, find their intercept on both x and y axis, together with some point. Then we draw those straight lines. Good. After drawing the straight lines, we are going to shade the feasible region. So the feasible region will be the region that satisfies both inequalities. So here we have the feasible region here being shaded. So here, look at it. We have the point 180. So these are the feasible region, and when you substitute the 180, you get 65. So it satisfies the condition, and 180 here is also satisfy the condition, and that will help us to identify this particular region. So the amount here reduced because I divide both. I reduce the equation to a list form which we can plot the graph. So in conclusion, which means that if the company uses this particular point, so these are the end point, these are the corner point. So if they produce the x represent the production of pesticide A, and the y represent the production of pesticide B. So if the company produce 100 of pesticide A and 80 of pesticide B, they are going to work around the constraint. It means that the laws, they are going to be in line with the law, and it will be legal for them to produce this number of barrels of pesticide. That is 100 for pesticide A and 80 for pesticide B. So we have an activity for you here. So this is one of the activity that you can perform your hands on, then try to find the solution for this particular problem. So the problem is a delivery company transport two types of packages, small and large. Each small package takes 1 unit of space in the truck and takes 30 minutes to deliver. Each large package takes 3 units of space and take 1 hour, 60 minutes to deliver. So it means that these are the constraints that they are trying to give it to you. So you need to be able to identify the problem and identify the constraint. The company operates under the following constraints. So we have the truck can carry maximum of 60 space unit per trip. The driver can work for a maximum. So this time the constraint for the number of space that the truck can carry, or maybe can be transported. And we also have the maximum number, the constraint for the hours to be for the materials, or for the small and the large packages to be transported per day, has also been given to you. So you need to be able to understand this particular constraint, to write your constraint, use the same principle to find the best solution to answer these questions. So the questions are to find the number of small and large packages the company should deliver per trip to maximize their revenue. So the company want to maximize their revenue. So each small package earns the company 15, and each large package also earns the company 40. So put this thing in mind. Each small package earns the company 15. So how many small package did they have to transport to maximize their revenue? How many large package did they have to transport to maximize their revenue? So it means that the problem here to it's about maximizing profit. So the number of small package will be X and the number of large package will be Y. I'm just giving you the clue of this particular problem. So the profit will be equal to 15 times the X plus 40 times the Y produced. So how much X and how much Y will help the company to increase their profit. So this problem is for you to try your hands on them. Good. So the summary of this our studies is we've learned about linear programming, which is a tool for decision making with constraint, and it helps in optimizing problem. So graph the constraint and find the feasible region. So how do? We graph the constraint and we find the feasible region and know which region with the and meaning the region that satisfies all the inequalities. After that, we evaluate the objective function using the corner point, because the corner points are the most sensitive part of the region to identify whether we are maximizing or minimizing the problem. So the maximum or the minimum value occur at those corner points. So the corner point is the point that is going to give you your problem, solve your problem for you, give you the solution of the problem, whether you are maximizing it or you are minimizing the problem. Thank you very much for watching this particular channel, and I will urge you to subscribe and like the button for us to continue giving you the best of mass education.